Alright, hello, I'm in the private oral exam guide. I'm in Chapter 4, Airplane Systems. I'm in Section C, Pitot-Static Flight Instruments. Alright, number 1. What instruments operate off of the pitot-static system? The altimeter, the vertical speed indicator, and airspeed indicator. The altimeter, vertical speed, and airspeed indicator. How does an altimeter work? Aneroid wafers expand and contract as atmospheric pressure changes, and through a shaft and gear linkage, rotate pointers on the dial of the instrument. Number 3. What are the limitations of a pressure altimeter? Non-standard pressure and temperature. Temperature variations expand or contract the atmosphere and raise or lower pressure levels that the altimeter senses. On a warm day, pressure level is higher than on a standard day. The altimeter indicates lower than actual altitude. On a cold day, pressure level is lower than on a standard day. The altimeter indicates higher than actual altitude. Changes in surface pressure also affect pressure levels at altitude. Higher than standard temperature. Higher than standard pressure. The pressure level is higher than on a standard day. The altimeter indicates lower than actual altitude. Lower than standard pressure. The pressure level is lower than a standard day. The altimeter indicates higher than actual altitude. Remember, high to low or hot to cold, look out below. So high to low or hot to cold, look out below. Define and state how you would determine the following altitudes: absolute altitude, indicated altitude, pressure altitude, true altitude, and density altitude. Absolute altitude: the vertical distance of an aircraft above the terrain. Indicated altitude: the altitude read directly from the altimeter, uncorrected after it is set to the current altimeter setting. Pressure altitude: the altitude when the altimeter setting window is adjusted to 29.92. Pressure altitude is used for computer solutions to determine density altitude, and true airspeed, etc. True altitude: the true vertical distance of the aircraft above sea level. Airport terrain and obstacle elevations found on aeronautical charts and true altitudes. Density altitude: pressure altitude corrected for non-standard temperature variations, directly related to an aircraft's takeoff, climb, and landing performance. How does the airspeed indicator operate? The airspeed indicator is a sensitive differential pressure gauge which measures the difference between impact pressure from the pitot head and undisturbed atmospheric pressure from the static source. The difference is registered by the airspeed pointer on the face of the instrument. What is the limitation of the airspeed indicator? The airspeed indicator is subject to proper flow of air in the pitot-static system. What are the errors of the airspeed indicator? Position errors, caused by the static port sensing erroneous static pressure. Slipstream flow causes disturbances at the static port, preventing actual atmospheric pressure measurement. It varies with airspeed, altitude, and configuration and may be a plus or minus value. Slipstream flow causes disturbances at the static port. Density error. Changes in altitude and temperatures are not compensated for by the instrument. Compressibility error, caused by the packing of air into the pitot tube at high airspeed, resulting in higher than normal indication. It is usually not a factor at slower speeds. What are the different types of aircraft speeds? Indicated airspeed: the speed of the airplane as observed on the airspeed indicator. It is the airspeed without correction for indicator, position or installation, or compressibility errors. Calibrated airspeed: the airspeed indicator reading corrected for position or installation and instrument areas. Calibrated airspeed is equal to true airspeed at sea level and standard temperature. The color coding for various design speeds marked on airspeed indicators may be indicated airspeed or calibrated airspeed. I'm holding off there.